With intersections and unions, the mathematical operation is mirrored by its name. Complements are too, but we'll need to make an important distinction. As I alluded to in the last video with an admittedly bad joke, the word complement is a homophone. In other words, there are two variations of the word that sound similar, but are spelled differently and have different meanings. On the one hand, we have complement spelled with an I, meaning a polite expression of praise. On the other hand, we have a complement spelled with an E, meaning a thing that completes or brings to perfection. For our purposes in set theory, the E spelling is going to be the important one. So when we think of complement, we can think more along the lines of complementary colors. Like for example, the purple and yellow color scheme I use for these videos, or the teal and orange color scheme you see commonly in films like Transformers or all over photos on Instagram. We say that these colors complement each other because when you add them together, they complete each other, per se, becoming whole, or, as we see it visually, becoming the color white. When they are separate, the color of the oranges is completely distinct from the color of the teals. In this sense, they're opposites, which is why they provide this nice color contrast that is so commonly used in photos and films. These colors are opposite of each other, but together they form a whole. This is true for sets as well. If we let this rectangle represent the universal set, and this circle represent some arbitrary set A, which we'll color teal, then the complement of A will be the region of the Venn diagram that is distinct from A, but completes the whole, or fills in the rest of the universe, specifically this orange region here. More formally, we say that for any set A within the universal set, the complement of A, written A' or AC, is the set of elements belonging to the universe that are not elements of A. Here, using either an apostrophe, which is probably most common, or sometimes a superscript C to represent the complement. So A complement is the set of elements X such that X is an element of U, it does belong to the universe, and X is not an element of A. For example, let's consider the set of letters of the English alphabet. If set A is equal to the set of consonants, B, C, D, F, G, and so on all the way until X, Y, Z, and yes, for this example we'll consider Y a consonant, let's find A complement. Well, since the universe is the alphabet and A is the consonants, A complement will be all of the letters that are not consonants. In other words, A complement is the set of vowels, A, E, I, O, U. Similarly, let's consider the set of digits. If set A is the set of even digits, then we can find its complement by determining all of the digits that belong to the universe, but not to set A. So all of the digits that are not even. More specifically, these would be the odd digits 1, 3, 5, 7, 9. Now, we can note a few things here. First, if an element belongs to set A, it cannot belong to the complement by definition. Likewise, if an element belongs to A complement, it cannot belong to the set A. Thus, set A and A complement are always disjoint by definition. Further, if we were to take the intersection of A and A complement, we must always have the empty set. Because like our colors teal and orange, they have to be in perfect contrast, completely distinct. And if we were to take the union of A and A complement, then we must always have the universal set. Just like mixing teal and orange form white, a set and its complement must complete the whole. To end here on another bad joke, if our universal set was the set of the like button and the dislike button, and we let set A equal the dislike button, then click the complement of A, or feel free to leave any questions you may have in the comments below. I hope you found this video helpful. Have a great rest of your day.